In this video, I'll show a few characteristics of the Unistellar Equinox 2 telescope, and then I'll show images I've collected with this telescope of Pinwheel Galaxy, Ring Nebula, and Dumbbell Nebula. For each of these objects, I'm going to show you a range of the collecting time, the exposure times for the image, and I'll do a little minor not very sophisticated editing of a few images in the video. So this Equinox 2 telescope, it's about 4.5 inches diameter for the mirror, and it's a fairly fast in collecting images telescope, an f4 focal ratio telescope. For if you don't know what that is, that's fine, but it collects images rapidly. It has a built-in database of objects, stars, planets, deep sky objects that you can access easily through a menu on a tablet or smartphone. I use Android system, but iOS, the Apple system, is also compatible with this equipment. On the app for the telescope, I can select an object from a catalog, whether it's a star, a planet, or galaxy, or a nebula, a deep sky object, and I can click on it and tell it to go to that location. Now, this is after the telescope has been set up and kind of oriented in the sky. There's an automatic procedure that the telescope can go through to orient itself. Once it gets on an object, then it will track that object across the sky. It will keep the telescope pointed towards that object, and as it every few seconds collects an image in its camera, it will automatically stack one image on top of another with correct alignment of the stars and make a brighter image of the object that's of interest. It does use a custom tripod. You cannot use your own tripod for this, but the telescope fits into a custom tripod. It's an altitude azimuth mount. It's not a polar aligned mount, altitude azimuth, but things work fine, at least for my purposes. A recent price I've seen on this, $2,499. I bought mine in 2023 for under $2,000. So watch for a sale, perhaps. So first object, M101, the Messier catalog, object 101 in that catalog, the Pinwheel Galaxy. And this is early morning for Universal Time, the time at Greenwich, England, on June 24th. I live in the suburbs of Omaha, the southwest suburbs of Omaha, and the sky is not good. There's a lot of light pollution. Roughly 41 degrees north latitude, 96 west longitude. There's a system of rating how dark your sky is, the Bortle system, and I estimate the number at my location is 7. I just set the telescope in my backyard and line it up and start collecting images. This will do a lot better if you have a very dark sky location. This first image, I let the light collect for 2 minutes and build up the image. I can watch the image build up on my smartphone or tablet. This image is raw right out of the telescope. It's a stacked image out of the telescope. It's not a single picture. It's the accumulation of 2 minutes exposure, what I call exposure. It's not collecting light all that time, but it snaps a picture, moves a little bit, snaps a picture. And there's no image processing for this image. And I'm going to go on to the next one. After 18 minutes, this is what I see in an image. Just a little information on M101. It's about 21 million light years away from us. Don't quote me on this, but I think Andromeda Galaxy is about 2.5 million light years. M101 is thought to be quite a bit bigger than the Milky Way galaxy, about 70% larger than the Milky Way galaxy. But because it's far away, it is faint. After 30 minutes, starting to see a little bit more detail in the spiral arms. 40 minutes, 62 minutes, 80 minutes, and 100 minutes. This was the last, I decided I had enough, and this was the last photo. But you can see clumps of gas in the spiral arms. You can't make out individual stars in this galaxy. Last year when there was a supernova in the galaxy, I could see that individual supernova. If I use a simple photo editing program, just photo in Windows, not very sophisticated, but I just up the brightness a little bit to bring out a little bit more detail, and not much time involved in collecting the image. While this image is collecting, I'm inside reading a book or watching TV, just occasionally looking at my smartphone or tablet to see how the image is progressing. And then this is probably a little overblown, but in that photo editor I cropped here, and just shows it's a little bit blurry. I did have some trouble with my particular telescope. I don't think the collimation of the mirror is quite on, but that's due to my own lack of skill. The focus, I think, is pretty good. There's a Bahtinov mask built into the tube cover, so it's easy to get a good focus. Let's go to a different object, M57 Ring Nebula. And again, we're early morning on June 24th. This is 68 seconds of exposure. And again, this is the image straight from the telescope. I've not done any processing to this. This is an object that's called a planetary nebula for historical reasons. In the 1800s, when this object and others like it were observed, astronomers thought they might be looking at a planet, as it did have a disk bigger than a pinpoint of a star, a little bit of color to it. So that name has survived, that label. This has nothing to do about planets. This is the shell of gas expanding around an old star. 10 minutes exposure, and the last one here, 16 minutes of exposure. And again, cropping the image. I have not tried to enhance the colors or the brightness of this. This is just a simple cropping. Next object is M27, the Dumbbell Nebula. And again, early morning on June 24th, 2024. After 68 seconds, we're already picking up some of the colors here in the nebula. It's another planetary nebula, expanding gas shell around an old star. 15 minutes, 55 minutes. I think 55 was the last exposure time. Here I did take this image into a photo editor and enhance the brightness a little bit. You can see how the labels around the edge are brighter, giving information about the photo. So again, very easy to do, simple editing, and again, too much blowing up of the image. It's not high quality enough to really deserve this much magnification of the image, but it is interesting in what you can do with very simple effort. So I have a website, gpclements.com, gpclements.com, totally free to use, no registration. I do not collect your name. I do not collect your email address and any other information. The site does not use cookies. It will not put cookies on your computer. But I'm a retired physics and astronomy teacher, and I've got over 500 YouTube videos that give short lectures on introductory physics and astronomy topics and work out sample problems that students may or may not find of interest. And there's also some other miscellaneous videos. They're all kind of organized. If you go around the YouTube system, you can see how they're collected. But in gpclements.com, I've got a list of all these videos with a little annotation that says if it's a lecture or if it's an example problem, how long the video is, and then a little description of the video. So help yourself if you're of interest in using this facility, gpclements.com. So I'm recording this with the snipping tool in Windows 11, just if you're interested in how I made this video. That's fairly easy to use as well. So happy observing if you're an astronomer, or keep expanding your knowledge in physics and astronomy.